Guys, welcome back to this concept based YouTube channel. Today we're going to discuss the next problem that we left in last class. Okay, so that is question number 5 of chapter 1 exercise 1.3. So for today problem, let us discuss this question number 5. What can be the maximum number of digit be in the repeating block of digit in the decimal expansions of 1 by 17? Okay, perform the division to check your answer. So we have to perform long division method or divisions method in order to check the decimal expansions, or in order to check the maximum decimal expansions that we got from 1 by 17. Okay, so for that, let us proceed to the problem. First we have this. So here just put 1. Okay, here it will be 17. 1, that actually it is 1 by 17, so you have to put it here 1 and here it will be 17. Okay, let us add point that it will become 0, then it is 10. Okay, and moreover, let us put this zeros again, that it will become zeros more. Okay, and 17 times 5 will give you 85. So if you subtract 85 from 100, then you will get how much? 10 minus 5 will be 5, and 9 minus 8 will be 1. Okay, so it will be 15. Okay, then 15 is little bit less than this one, so you have to put zeros again, since there is a point, so you can add zeros. Okay, so 17 times 8 will give you how much? 7 8 are 56. Okay, 7 8 are 56, and 8 ones are 8. 8 plus 5 will give you how much? 12. 7 times 8 will give you 56. 5 in hand. Okay, and 81 is 8. 8 plus 17 times 8, so 7 8 are 56. Okay, and then 5 will be here. 81 is 8. 8 plus 5 will be 13. Okay, here it will be 136, and then subtract 136 from 150, then it will get 14. Okay, as remainder. So 14 is less than this 17, so I have to multiply with 8 again in order to get some numbers which is closest closer to this number. Okay, that is 140. Then I will get a 136. That if you subtract 136 from 140, then it will get how much? 10 minus 6 will give you 4, and here it will be 3 minus 3, that means 4. Okay, since we already put some point, that we can add zeros again. Okay, then let us multiply this 70 with 2, and then we will get how much? 34. Okay, 40 minus 34 will give you 6. Here at this point, that we can add zeros again. Okay, so how should we do again? 17 times how much? 3. Okay, 17 times 3 will give you 51. So 10 minus 1 will be how much? 9. Okay, so here at this point, then we can add zeros again. So if we multiply with 5 again, that means 85. 90 minus 85 will give you 5 as remainder. Since we already at a point, then we can write it. How can we write it? Here you can write zeros again. Okay, then 50. So 17 times how much? That is true. That means 34. 50 minus 34 will give you how much? That is 16. Okay, here it is point. That means here you can add zeros again. So 160. So in order to get the number exactly equal to this or much closer to this, you have to multiply 70 with 9. Okay, if you multiply 70 with 9, 9 times 70 will give you 63, and 9 1 are 9. 9 plus 6 will give you 15. Okay, so if you subtract 153 from this number, then it will get this 7. Okay, here it is point, and the remainder that we got, it is less than this, then we have to add zeros again. Okay, that means 70. So in order to get the number much closer to this number, that is 70, you will have to multiply 70 with 4. Okay, if you multiply 70 with 4, then it will get 68. Okay, then you will have to subtract this number 68 from 70, that it will get 2. Okay, here at this point, then we can add zeros again. Okay, 17 times will give you how much? 17. 20 minus 17 will be 3. Here at this point, that we can add zeros again. Okay, that means 30. 17 times, how much would it be again? 17 times 70. 17 times 1. Okay, will give you how much? 17. 30 minus 70 will be how much? 10 minus 70 will be 3. And 2 minus what will be? 1. Okay, that means 30. But 30 is less than this 17, so you have actually you add point. So by making use of this, you can add again zeros more. Okay, and then what will be the number here? That is 130. So in order to get the number much closer to this, you have to multiply this 70 with this number. Okay, 7 are how much? 49. 71 is 7. 7 plus 4 will give you 11. Okay, if you subtract this number from this, then it will get how much? 10 minus 9 will give you 1. And then 2 minus 1 will give you 1. But the number that we got as remainder is less than the one that we use for dividing this number. Okay, because of that, you have to make this one bigger than this. Okay, in order to do this, here at this point, then we can add zeros again. So if we add zeros, then we have to get the number much closer to this number or exactly this number. Okay, in order to do this, 17 times 6 will give you how much? 7 times 6 will be 42, and 7 times 6 will be 42. 6 over 6. 6 plus 4 is how much? 10. Okay, so if you subtract 102 from 110, then will get how much? 8. Here is this point, that we can add zeros again. Okay, so in order to get this number, or in order to get this, the number that is closest to this number, you have to multiply 70 with how much? 4. Okay, then it will get 68. After subtracting 68 from 80, it will get 12. Okay, then here at this point, you can add zeros more. Okay, 17 times how much? 70 will give you how much? That is 119. Okay, so if you subtract this number from this, then it will get 1 as remainder. Okay, so that's it. Then after that, 17 times how much? Actually, the remainder that we got here, it is 1. Okay, then if we add point, then we have to continue with same as the one that we did here. Okay, so likewise, after this decimal expansions, or after this digit, the decimal expansions will repeat itself, same as this one, again and again. Okay, so because of that, in order to represent lengthy mode into short mode, we just use bar. This bar represent this decimal expansions is repeating itself again and again. So this is the maximum decimal expansions that we got in dividing 1 by 17. Okay, so that's it. Is there any confusions regarding about this? If there is no problem, then let us move to the next question. Okay, in the next question, what is the next question? That is, let us look several example. Okay, here the question has said that let us look several example of rational number in the form p by q. Okay, where p and q are integers with no common factor other than 1 and having terminating decimal representation. Can you guess what property q must satisfy? Okay, so that means actually the number is in the form of p by q. Okay, in the form of rational. In case of the number should be rational, q should not be equal to 0. That will be the first point that will be remembered for us. Okay, that is needed for us to remember. So this is the condition that number has satisfied in order to become a rational number. All right, so the question has asked us the number is in the form of p by q and it is terminating. Okay, if it is terminating, then what should be the values of q? So you have to guess this one. Okay, so simply q, in order to be terminating, q should be 2, or the prime factorizations of q has only prime of power of 2 or power of 5 or but. So this should be the answer for this q. Okay, so that's it. Then let us move to this number. So what is question number 7? In question number 7, so write 3 number whose decimal expansions are non-terminating, non-recurring. So you have to write three decimal expansions, okay? Three decimal expansions whose decimal expansions are non-terminating, non-recurring. So let us take this one. That is simple. So we just take this number. This number are decimal expansions that doesn't repeat itself again and again, but moreover it is also non-terminating. So this is the expansions that is non-terminating and non-recurring. Okay, then let us move to this question number 8. What is question number 8? In question number 8, find the three different rational number between the rational number 5 by 7 and 9 by 11. Okay, so I have to find a rational number between these two rational number, that is 5 by 7 as well as 9 by 11. Okay, so firstly we have to find how much decimal expansions that we got. In 5 by 7 we got this much, in 9 by 11 we got this much. So in between this number, or in between these decimal expansions, I have to find two different irrational number. So as we did in previous class, that is the number that is non-terminating and it is non-recurring. Okay, so this kind of number is irrational number. Okay, so same as this, we just pick it, the decimal expansions in between this, okay, which is non-terminating and non-recurring. Okay, so this kind of number represents the rational number, so we just pick in between these three irrational numbers. So this is the irrational number that is in between this number as well as in this. Okay, then question number 9. In question number 9, what does we have? That is, classify the following number as rational or irrational. So under this we are given with 5 options. So among these we have to choose which one is rational number and irrational number. So for that, let us proceed this one. So how much number did we got here? It is 23. Okay, so 23 is the rational number. All right, actually in the case of number should be rational, it has to satisfy this condition. Okay, but provided p and q should be an integers. Actually root 23 root over 23 is not an integer. That means it is not a rational number. Okay, in case of number should be irrational, it has to satisfy p by q condition and p and q values should be integers. But here the values of p, that is root over 23, it is in the form of integers. No, it is in the form of, what is this? It is not in the form of integers. So this number cannot satisfy this condition. Based on this, we can conclude that this is belong to irrational number. Okay, then we are going to move it in Roman number 2, whether this one is irrational or not. Let us check it. Okay, since if it is like this, then it will be irrational number, but from that we can take it out as by breaking this root by squaring 15. Okay, square minus root, no, square and root cancel, then the 15 will come out. Okay, 15 is integers and 15 can satisfy p by q condition, and moreover 15 is an integers. Okay, so based on this conclusions, or based on these definitions, we can conclude that this is rational number. Okay, same as this. Okay, 0.37. So this number, this kind of decimal expansions can satisfy p by q conditions, so easily we can term it as this what is belong to rational number. Okay, and even in this process 7.478478, this kind of number can also satisfy p by q condition, so we can conclude that this is belong to rational number. Okay, but here let us check this one. So that is 1.1010. Actually the number is non-terminating, but it repeats itself again and again. The number is non-repeating, but the number is unending, or the number will go on like this. The decimal expansion is non-terminating. But let us check this one. That is, this one is not repeating, this one is not repeating or recurring. Because of that, there is one problem, or there is one property, that is, if a number is non-terminating and non-recurring, that we conclude that distributive expansions belong to irrational number. So by making use of this property, from that we can conclude that these distributive expansions belong to an irrational number. Okay, so that's it for today. So if you have any kind of difficulties in understanding this, please let me know in the comment sections. That's all for today. Thank you.